The next session by Jordi, who you already met, is on neuro-diverse AI, enhancing creative problem solving through unconventional cognitive strategies and morphological designs. So we're moving to another field that another group of people will feel they don't know anything about, but this has been a recurring theme of the entire day today. I'm just going to move some chairs. But Jordi, please, take it away. Oh, yes. You might need that.
Okay, thank you so much. I'm very sorry because you need to listen me again, those of you who are still here. So I will try not to be very philosophical in the sense of very boring. I will not talk about philosophers, so be happy about that fact. I want to talk about something that I'm just thinking in the last times. It's not a real thing. I have not experiments, I have not raw data. It's just ideas that inspire me. It's part of my research. It's done in that way, just thinking, and then trying to convert thoughts in some kind of applications of real things. And I want to talk about you about neurodiversity. So when we talk about AI or cognition, in most of times we are talking and having in mind neurotypical guys, normal people, what we define as normal people, but not all people that are under our interest are normal. In fact, I think that it's just completely the opposite thing. There are plenty of very interesting guys who are neurodivergent. They are using different ways of making brain and cognitive processes that are not following the classic rules. So we can find several examples about that. Ludwig Wittgenstein, for example, one of the greatest philosophers of history thing, Albert Einstein, Darwin, for all of them, we don't have real tests checking this information, but we know about their biographies, their acting, their way of writing, that they were not neurotypical. I'm not saying that they were, because they were smart or very creative, were not neurotypical. I think that they have a specific ways of thinking and this specific ways of doing things at a social and personal level that are completely fitted with being non-neurotypical. For example, Nikola Tesla, we know that he had plenty of behaviors that can be explained considering him like an autist. Yeah, it's bad or it's good. I think it's good for some things, it's bad for other things. But if we check his achievements, we could define him as an autist, and it's something that it's relevant. So perhaps it's something interesting into analysis of brain and brain simulation or models about brain that are related with that. I don't know if you are aware, but Bill Gates, Jeff Bezos, and Elon Musk, all of them are neurodivergent. All of them. All of them are horrible people, yeah, and very rich too, but successful. So for different reasons, Asperger, autism, attention deficit hyperactivity disorder, or Elon Musk even told in a very recent interview that he had Asperger syndrome. So these are things that sometimes we relate with very intensive forms of autism, but on neurodivergent people, but they are different scales of suffering from this condition, and in not all cases it's like blocking the whole functional. In some cases yes, but in plenty of other cases not. It's something that not directly this one that I have been exploring. I have a paper some years ago called The Benefits of Being Wrong. It's something that it's really interesting for me. When everybody was talking about ambient intelligence, I started to think and publish a paper about ambient stupidity. It's something that it's much more real with real cognition. So if we analyze the real functioning, we can understand better the good benefits, the winning strategies that are not always the same. We know that the best guys in secondary school are not the successful guys at the university, are not really in life, because in life you don't have exams with specific rules, specific topics to be solved and anything else. You need to be creative, resilient, plenty of skills that are never trained at school, never. So life is much more complicated. So cognition is much more complicated than to explain why some specific guy has intelligence coefficient of whatever. So if I ask you to find 5s and 2s in this image, it's possible, it's not so difficult, but if I show you in this way, it's much more easier. So imagine that you could have this kind of automated skill, then you could find patterns much more easily. It's something that happened to Richard Feynman, for example. He had a specific way of synesthesia that allowed him to combine visual inputs with colors and data information with colors. So it's something that he never chose. He was born with this skill or problem, I don't know how to define, but being a mathematician, it's like, whoa, fantastic, because you can find patterns and numbers much more quickly. It's not something automated. You cannot train this thing. Yeah? So why not use this kind of disabilities or of differences trying to integrate multimodal information? Perhaps we are trying to, perhaps the brain is not the best, the human standard neurotypical brain is not the best machine to process information. In fact, it's not the best machine. If you check the wheel of biases that humans are committing, it's crazy. It's even very sad to see that we are so bad reasoners all the time. And we are doing very, very crazy things, because before to come here, I was checking just for fun pictures of priests from very different cults all around the world blessing data servers. Really, you can check. A priest blessing data servers. You can find, or for example, when in Russia the Soyuz rockets are launched, there is an Orthodox priest blessing the rocket. And why we in 2024? Why it's necessary? Why do you need to pray? Yeah, even the astronauts, American astronauts that went to the moon had a Bible, hidden Bible, and they even quoted the Bible and this. Why? This is not rational. It's completely irrational. But this is the way that we are functioning. We are following dozens of heuristics all the time. We are not coring. We are closing all our ideas all the time. So perhaps in some cases is that just that the normal rational process is not so rational. In other cases, the real thing is that other ways of processing information can be really interesting. So there are plenty of neurodivergent possibilities. I'm not saying that all of them are fantastic. Most of them are really not funny for the people who have them, but in some cases allow other ways of dealing with data. And this is the interesting thing for me, how to generate new artificial systems that can process data in a different way. Because again, bioinspiration, it doesn't imply by a copy. Yeah? It's inspiration. Our brains were generated by evolution in a specific conditions that are not related to living in cities and dealing with numbers. So this is not the best machine for dealing with numbers. Perhaps if we want just to work with numbers, need to create a different kind of system. So when we talk about these things, what we see is that we are talking about different things, about patterns, heuristics, weights, values. And for example, when we check at the non-neurotypical population, we can find other kind of things. For example, a different way of dealing with multimodality, different ways of connecting data. In some cases, wrong. or not very useful. For example, one of the problems of people with autism that have like hyper focus and obsession with detail is that sometimes make causal relationships between patterns, some kind of observation of data with other actions. For example, if you were sad someday and you were wearing a specific dress or drank something specific, I can think that this is the connection that explained that you were sad. and perhaps it's not the reason, but perhaps in my mind, if I am autistic, I think that this is the connection. And this is one of the problems of autists, that they process much more data with much more precision, but they have problems making generalizations. In some cases, in another ones, precisely the more amount of data in their minds allow them to process more precisely this kind of information. In any case, what is truly fantastic for me is to think that at some point this allows the divergent thinking. This is the holy grail about, and everybody in AI is trying to do the same, to find the general reasoning machine that can think and be creative. It is the typical thing. We want machines that are creative, that are innovative, that are able to generate new meaning. This is like, whoa, fantastic. Not so fantastic. It's like a kid. Kids are fantastic until they start to say things that are out of your control. And then it's not so funny. But in any case, this is our thing. So perhaps our AI's bioinspiration could be working in that connection. For example, when we deal, this is an example of has some years of the Google Cloud Vision system in which they were trying to see if with artificial vision some machine could reproduce. I think that can repeat, yeah. And according to the position of the thing, the machine thought that it was a rabbit or it was a duck. So this is a real thing in real data scenarios, that there are not exact solutions for exact situations. There are plenty of context, multimodal possibilities, non-temporal definitions, because it's very easy to say that you can find some kind of, you just can observe something, but for observing something you need to clarify first which is the temporal framework in which you want to observe, how many times do you need to see something that is repeated, and then accept this as a model for achieving some kind of results. So we need to define things in real scenarios that are not so easy. Easy things are only in the minds of researchers, but the real life is extremely difficult. So perhaps if we need to solve this, there is not a solution, because of course it depends. It happens also to humans. It depends on the position that we think that something is something or not. In order to reply to this example or to find a solution, could imply to do more questions. Which is the sound that this animal produces, how it moves, what it's eating, but you cannot infer from this image. So this is the real thing with our world. We don't have never all the data with good quality data and infinite time for processing the data. And this is how humans operate. For that reason, all these dozens of biases have helped us during evolution for taking decisions. But the real thing is that are mistakes for doing things. When we are trying to be precise, we find plenty of problems. So perhaps some kind of approaches like the Hopfield and Hinton studies that allow them to receive the physics prize, and even for Hasabi the chemistry prize, and he is not chemist. It's crazy. It's absolutely crazy, but it's fantastic. It gives me some kind of opportunities for receiving the Nobel, I don't know, for something, if at some point I apply for it. But perhaps we want something else. Perhaps our current AI, it's very successful. I think it's very successful. I'm not the typical human is saying, whoa, they are still not able to do blah, 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 blah. They don't prepare me the coffee, of course. No problem with that, but they are doing things incredible. Generative AI 2 years ago was crap. It was horrible. I remember that I had access as a researcher to the 2 and 3 versions, and it was okay, normal chatbot, nothing else. But with the 3.5 version, changed everything, and with the 4 version, it's incredible the amount of things that can do, even wrong things, but the good ones are fantastic at everybody saying, whoa, but they are copying things and doing things like humans, and yeah, even better. Last week appeared a paper that said that in a very controlled experiment, humans preferred literary productions generated by AI than by human beings. In the group of human beings was placed Shakespeare. So imagine, yeah, perhaps we are not so original, perhaps we are not so creative, perhaps we are not so. Perhaps we are just following patterns. It's something that for me, it's really stupid. People saying, whoa, but these machines are not creative. Perhaps it's not creative, but how many people do you know that are creative, truly creative? Most of us are following rules. If I am an academician, if I want to publish in a specific journal, I must quote in some way, use a specific strategy of writing, a specific style of writing, even a specific type of English, of ways of doing things. And if I don't follow strictly the rules, I will not be published. So I am creative? No, not at all. Yeah. So this is something that we need to have in control. So what we need to do is to think that at the end, what we are trying to do is to inspire into biological examples from all kinds, from very minimal things, for example, slime molds or insects until arrive to human beings, especially those beings that are social are very interesting for us. As an example for the performance are much more complex tasks, and at the same time, there is like a opposition between generalization and specialization in AI, perhaps except in the case of expert systems. What it has been tried to do is something to, again and again, it's a holy grail to obtain a general thinking system that, again, it's very simple to do, but I don't know people that can think in a general way about anything. Most of us are very specialized, doing very specific answers about very specific things. And at the same time, these models are very mechanistic, following very specific sets of rules that in some cases humans are not doing, but when humans are not doing, they are even thinking out of the box, at even breaking the rules that are expected. Just check the history of science of the last 3 centuries, and every time that there is a true revolution, the automatic response of the rest of scientists is, you are crazy, you are wrong, all the time, in all cases. Never everybody says, whoa, you are true, Copernicus, I accept your ideas. Oh, fantastic, Darwin, we will accept everything and we'll change all our models. Never happens, never. Even very good models are not accepted theoretically. Remind the case of Tesla in the United States. His solutions were better than the other ones, but were not accepted for different industrial and racist processes. So perhaps these models are mechanistic, but need to be translated into other kind of things. Again, also the existence of that data bias and all the process of doing and processing these things. And finally, the necessity of efficiency is something that up to very recently, except for the computational costs of running machines, it's something that it was not explored because it was expensive, but no one required a supercomputer for doing basic calculations, except for the atomic bomb and cracking code of the Enigma machine or things like that. But for most of scientific cases, we never needed very huge computers. But today, just for running basic generative AI, the computational costs and energetic costs are really huge. So now we are starting to talk, and besides, because there is an ecological agenda, to talk about the necessity of being much more efficient. But it's something that is also related with capitalism traditions. So what we are seeing that perhaps we need to change from the current neural networks and artificial neural network architectures based on some kind of archetypical reductions of what we thought about the brain, like predictability, optimization, and generalization, into another kind of things or of thinking that can be much more adaptable, much context sensitive, and perhaps using non-linear problem solving techniques. That is something that it looks like crazy because you are losing the control. Perhaps you are entering into much more problems, but perhaps in some kind of cases is much more better. Okay, this is too much information. So perhaps what we need to do is to start to talk about the use of models based on non-neurotypical cognition as a base models for thinking about solving questions in different kind of fields. For example, with this kind of systems, we could, for example, try to reproduce the necessity of hyperfocus. One of the interesting things when we are talking about AI, or even guys doing research on generative AI, is that how we can achieve intentionality or attention, because attention, again, all throughout the last 3 centuries, the holy grail of philosophers was logical thinking, logical computing. When we achieved to create very precise logics for doing that, and then we obtained we even created machines for doing that, what we discovered is that our models are wrong all the time. All the time there are inconsistencies, I don't find not coherent relationship between all the concepts, and therefore what we see is that at the end the whole process of learning is based on degrees of belief and degrees of approach. We never have a full complete system. Even in this moment, we don't have a full agreement about the model about the nature of the universe, about the origin of the universe and about the end of the universe. We have different hypotheses. Some of them are much more plausible, but in any case, we don't have a full general system with a central organized theories. But it doesn't imply that all of us are crazy or are very sad or that flights are not flying or things like that. So we are managing uncertainty and degrees of belief in several kind of things. So these kinds of non-directly logical aspects of dealing with data are fundamental, and some of them are related with neurotransmitters, roles and hormonal roles in our bodies that manage this kind of process. And one of them, for example, is attention. How could be if we could define systems that could be hyper-focused in their attention? How to translate this into one kind of artificial system? Or using kind of a spiky memory, yeah? Based on specific knowledge related with very context-dependent things that in some cases can be wrong because doesn't allow good generalization, but at the same time can help to understand deeper and deeper some kind of a specific necessary relationships in sets of data. Another thing is it could help also to work on nonlinear associations that it's related with divergent thinking. Divergent thinking, it's not just crazy thinking, but it's related with the possibility of using different sets of rules. So, and sometimes you need to break the rules for making some kind of advancement. Why if, but you need to evaluate when it's a good idea or not, but we don't have answers. At the same time, the sensory sensitivity is something very, very interesting. Do you need also to remind that despite we know that our sensory processing, it's not the processing of the reality, it's just the processing of some thresholds of reality. We have instruments for dealing with that and explaining things that are beyond our visual competence and auditory competence. At the same time, we think and we reduce in normal thinking all to the sets of data we can process. This is the real thing. We are not taking into account all this data when we are thinking in a normal way. In fact, most of humans still says that the sun arises and then disappear at some point, and we explain to our kids every day. Something that it's not real. We are moving, but we are not thinking. In fact, from a natural perception of the world, all of us are still living in the 3rd century before Christus, in the normal perception, because we know that we are moving at this moment at the movement of the Earth around the spinning Earth of our 24 hours. We are spinning around the sun. The whole solar system is moving, and the whole galaxy is moving, and the whole universe is expanding. And all these things are happening. For example, the daily spinning, it's at almost 50 kilometers per second. The second one around the sun, it's close to 300 kilometers per second. And the next one is 400, and the next one is 600 kilometers per second. And our perception is that we are quiet. So our perceptual system is not percepting the real thing. So this sensitivity, it's important to describe the level of detail we want to obtain from data. And this is something very important. When we analyze something, and one of my research fields is causality, we cannot just observe. You need again to define the level of the things that you are observing, to find some kind of patterns. Time, scale, molecular, physical, which kind of physical, when you start, well, it's much more difficult. And finally, the problem of communication. So this is a very stupid example about, of course, a crazy idea about how to generate this kind of neural nets using a different kind of things. For example, introducing stochastic nodes or memory modules that affect at different points the processing. That it's something that looks like it's happening in the brains of non-neurotypical guys. And it's something, it's important because it doesn't only affect can affect to machines, but also to humans. Remind the game between AlphaFold, iAlphaGo, and Lee Sedol. At some point it's called the move 37, AlphaGo did a very unexpected movement that no one player in more than really documented 2,000 years has ever done, but it was a very good movement. Lee Sedol was what's happening, yeah. But the good thing is that the machine did something completely unexpected. But in the next game, Lee Sedol also said, "Okay, I cannot lost anything else. Why not?" And he did something that it's called a good move in the position 78, in the movement 78, that allowed to a human to think really completely different. So it's not machines against humans. These machines going to the next step allows humans to think also into the next step. And this is the real interesting thing. So just for finishing, I think that this kind of approaches can allow to generate a much more creative AI using different kinds of approaches by inspiration. At the same time, it's an AI that has very interesting aspects in relation to socialization and also how this is important for the relationship, something that is always neglected when we are talking about cognition. Cognition is not happening in isolated brains. It's something that happens into dynamical relationship between agents, cognitive agents, and a true AI and a true intelligent, for example, a robotic community will have to work in cooperation. That is the basic of things. And finally, some kind of things could be useful for doing kinds of medical diagnosis based on different patterns of looking for information. So, and this is the the final, I think that this kind of non-neurotypical AI could imply some kind of paradigm shift in AI, or at least a different approach to thinking about AI. Perhaps using these kind of approaches, in some cases we can improve our efficiency, energy efficiency goals. And finally, something very, very important is that in order to achieve this, we need interdisciplinary teams. That it's something that must be repeated all the time, that from single teams are not able to do anything at this moment of our advancement of science. So thank you so much. 26 seconds.
So very quickly, 20 seconds for questions? No, just kidding. Thank you, Jordi. I just have a small reaction on this unconventional thinking, and to connect with Dražen's comment on the eradication of cancer. There was actually an AI system, the defense system, which was tested very recently, and it had a target which it had to destroy, and it had a commander that would give it instructions, and then the commander gave it instructions not to destroy the targets, and then the system thought out of the box, flipped around in the simulation, obviously, and attacked the commander, because if he takes him out, then he is the blocker for destroying the target. So out of the box thinking, it also blows up in your face sometimes.
Yeah,
but
it was an example explaining to a military conference that the press said that it was a true example that has happened, but it was just an example. If the system was ordered to kill the target, and the only thing that they didn't allow to do that was the human operator. The idea was to kill the human operator in order to kill the target. So it's something that for humans it's logical, but logics it's not something that it's in the world.
No, definitely. And I really loved your presentation, because it kind of wraps our heads around all the different perspectives that we had today. We're going to thank you. Oh yes, questions. I'm sorry, I'm also, there we go. Do we have another microphone in the room? No, you need the microphone because we're recording.
Thank you for this excellent lecture, really. I like this approach that you showed us, so that I will just highlight some tokens from your lecture, such as linearity with non-linearity, divergent thinking, divergent solutions with convergence of solutions. So we have a lot of algorithms today, heuristics, meta-heuristic simulations, probabilistic, different algorithms. But in all algorithms, we are looking for the, let's say, convergence of mathematical model. Is it like this? So we are doing usually, what we are doing? We are doing linear algebra, rectification, linearization. So this is maybe the thing. I know that in academic, because I'm also PhD and I'm a researcher, we are dealing with the different, let's say, tests that are non-linear. So what do you think, how we can establish novel algorithms in this kind of environment and architecture that could provide divergent solutions? Because maybe this is the key of the future. Thank you.
I think that basic thing is money. Giving money, grants, and good research opportunities for exploring different kind of things. That I think it's the only possibility. Because the problem with technology is that when something works, everybody works on the same. Just investing more people and more time and more money doing the same. So perhaps at some time, some kind of possible good technologies or possibilities are not explored just because are out of the main tradition or the main industrial necessities or the main requests. So this is the real thing. For example, generative AI was not necessary. Really, was not necessary. But they invested.
ChatGPT.
Yeah, but there were plenty of chatbots and things like that, but it made no sense at some point to invest so much money trying to obtain something, because I remember attending to plenty of conferences of robotics, and the stupid guys were the linguistic ones. all the other ones, mechatronics, things, blah, 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 fantastic. But everybody said, whoa, language, natural language, it's so difficult that it's unsolvable, really. But what we had not in mind is that the new big tech corporations would have an access to the huge databases that nobody had idea. So there was not a social in the industrial context in which that thing could be possible. So it's normal that when these companies had so many data and even stole a lot of data at the same time, because it has been trained with not legal sets of data, that this kind of thing could be achieved, investing money. They had data and money. Yeah? It's something that everybody could have, but we don't have enough data and not enough money. And besides, the state of the art at technological level was not new. But the real thing is at the beginning of this generative AI in the last 4 years, the technology has not changed a lot. The basic mathematical models used for running those things are not new, and were not new. Transformers were not created in 2019. Yeah? So the real thing is that what changed were the conditions, and then the opportunity for some kind of specific communities of thinking about revenues, about money. So I think that the real thing for achieving these kind of things is investing, not wasting money, but investing. Just select good projects and then invest money. For example, with the Blue Brain project, it was a European flag project, and was invested like half of the European budget for years. And it was a huge investment. But
yeah, but it was, it was under a different scheme though. So yes, it was a huge investment, but I think there's a misunderstanding that the amount that went into the Human Brain Project was diverted from core EU funding, like and which potentially deprived people of ERC grants and stuff. But I think that's not quite the case, because back then the EU had a pool of money under the so-called ICT route, which wanted to fund these flagships. No, just for the record. Yeah. So because I often hear these things come up. So whenever I can, I just try and provide a more factual perspective.
Yeah. Okay. Yeah. But what I am trying to say is that the real thing is to have money and then invest into research, and then sometimes it works and sometimes not. But unless you invest time and money, it's impossible. It's not just about thinking. You need resources and professionals, and then support at least for, I don't know, 10 years, something like that. Otherwise, it's impossible. And the other thing is that we cannot compete at this moment. It's something that, for me, it's completely new. Up to the 1970 and 1980, most of the big advances in science, in all scientific fields, were done with by national efforts. In some cases, some companies, you can check late 19th century Germany, big chemical companies, but nevertheless they had support from the Wilhelm Gesellschaft. But in any case, now it's the first time that the cutting-edge technologies for producing knowledge are in hands of private companies. So Meta has much more power than any kind, and Google and Meta and are really leading this kind of research. So it's something strange also. And we don't have enough money and enough data for fighting with them. And this has changed the rules of everything. They are not patenting things. They don't need, of course they are patenting, but they don't need to show what's happening. They just monetize the results all the time. So.
All right.